So let's look at Pythagoras' theorem in 3 dimensions. So if we want to solve problems in 3 dimensions, what we have to do is we need to use Pythagoras twice. And again, we're using our properties of 3D objects in order to help us work out how we can apply Pythagoras. So in this first example, we've got a cuboid that has side lengths of 2 centimeters, 3 centimeters, and 6 centimeters. And we want to work out the length of the diagonal AF. And that is this diagonal going across from one corner of our cuboid to the other. Sometimes you'll hear it referred to as a space diagonal. Now, how can we use Pythagoras? So the first thing we're going to do is we're going to look at the base. So we've got rectangle ABCD. And you know that a rectangle has 4 right angles. So that means that the angle at B and the angle at D are both right angles. And the angle ACB, or triangle ABC, is going to give us a right angle triangle. So let's mark that in. So we've got triangle ABC, and we know that angle B is going to give us 90 degrees. So let's draw a sketch over here. ABC, angle B is a right angle. Now we know that AB is 6 centimeters, and we know that BC is the same as GF or FG, which is the depth of our cuboid, which is 2 centimeters. And so we can work out what the length of AC is, because we need that in order to be able to work out our space diagonal AF, because our second right angle triangle is ACF, because we have another right angle at angle C in ACF. So let's apply Pythagoras to our first triangle. So we're going to go to our right angle and we're going to draw an arrow. We don't know what AC is, so we know that we're going to be adding. So we've got AC squared equals 2 squared plus 6 squared. And that gives me 36 plus 4 is 40. And then if I wanted to work out what AC is, then I would obviously square root that, and I'm going to leave it as an exact value. I'm not going to do any rounding. So for my second triangle, I have triangle ACF. So I've got A there, C there, and F there. My angle at C is my right angle this time. Now I've just worked out what AC is. It's root 40. And I know that CF is the height of my cuboid, and the height of my cuboid is 3 centimeters. That's root 40 centimeters. I better put that one over there as well. So I want to work out what AF squared is. And I know that AF squared is AC squared plus CF squared. Now AC squared was 40. And CF squared is going to be 3 squared. And that's going to give me a total of 49. And so AF is going to be the square root of 49. And that's going to give me an answer of 7 centimeters. Now the second example is to calculate the vertical height VM in the square base pyramid to 1 decimal place. The square base ABCD has side lengths of 5 centimeters. So that means that AB is 5 centimeters because it's a square base, and we know that BC is 5 centimeters because it's a square base. The lengths VA, VB, VC, and VD are each 8 centimeters. So imagine that this was like a flagpole, and we're attaching a string from the top of that flagpole to some point a distance from the bottom of the flagpole. These are like hypotenuses of our right angled triangles, and these are all going to be 8 centimeters. M is the midpoint of that square base. So the first thing we're going to do is we're going to work out the length of AC, because we can form our right angle triangle ABC, and then we can work out the length of AM because it is half the distance of AC. So if we draw ourselves a sketch, we've got ABC, our right angle's at B, and we know that AB is 5 centimetres and BC is 5 centimetres, and we want to work out this missing side over here. We're going to go to our right angle. Our missing side is the long side, so we know that AC squared is going to equal 5 squared plus 5 squared, and that's going to equal 50. And if I wanted to work out the actual length of AC, then I would have to square root that. And again, I'm leaving it as an exact value. I don't want to round it. Now, I want to know what the length of MC is. And I know that M is a point halfway between A and C. So I need to half my root 50. So MA is going to equal root 50 over 2. Now, if I go back to my original question or my original diagram, I now want to look at triangle AMV, which is also a right angle triangle. So if I draw myself another sketch, this time I've got AMV. Now I know that AV is 8 centimetres. I know that AM is root 50 over 2. And I know that my right angle is at angle M. So I'm going to go to my right angle and I'm going to draw an arrow to the long side. This time I've got a value, so I know that I'm going to be subtracting. So in order to get VM squared, I'm going to do the long side squared, so 8 squared, take away root 50 over 2 all squared. Now, if you've got a calculator, it will obviously do it for you. But if we've got 8 squared, and we know that the square of a third is the value itself, so it'll be 50 over 2 squared, which is 4. And that gives us a value of 103 over 2. Now remember, that's VM squared. We want VM on its own. So VM is going to equal the square root of 103 over 2, which gives us a value of 7.176 and so on. Now, if we go back to the original question, and maybe we should have highlighted this at the beginning, it's asking us to round to 1 decimal place. So our final answer is going to be 7.2, and our units are going to be centimetres. So the height, or the vertical height, of our square base pyramid is 7.2 centimetres.